is that it's just going to be more layers all the way down, and that there's only at the very nucleus of the planet is there a really solid core. I don't know. That's
Yeah,
my prediction.
I agree with I can agree with that.
It's
I
not
can't.
just my
Yeah.
prediction. It's I think it's Edmund Halley's prediction. I could be wrong though.
The important
He could have been a
scientist.
little different than what I'm saying. I just think it's like that.
Yeah.
Which brings us to the magnetosphere and why on this show we talk about stuff like that the Earth is a toroid, that it's a donut, it's a torus. The Earth is well.
Donut, huh?
I'll explain because no,
Yeah, explain
it's not.
indubitably.
It's not that it's true. It's not that the this planet is shaped like the intro screen um, planetoid, where it's literally a donut. But
Okay,
in some senses, it is a donut. It is like
okay,
a torus, and in one of these senses is the our magnetosphere is toroidal, and it's like this. It's like a butterfly onion shape kind of thing,
okay.
and then it
That's
rotates
interesting.
around, and it's like so it's like a donut. It's like a magnetic
Yeah, yeah,
electromagnetic
okay.
donut,
Gotcha.
and that's part of our planet. It's kind of like the outer onion shell. It's the
Uh,
or something, or it's just like the husk of the tomatillo of this tomatillo Earth,
gotcha.
and the husk is a donut or something. Anyway, that's getting a little tortured, but the idea is that in electromagnetically, our
Yeah.
system is kind of like a donut, and then we move on to a different conceptual space, the fourth
Okay.
dimension.
Fourth dimension.
Dr. Ravenblack, are you ready to enter the fourth dimension?
Sure, why not? We'll enter the fourth dimension.
You and I inhabit the fourth dimension all the time, as it is time
Oh,
itself.
dude. Time in itself.
Yeah,
Okay. I
alleged
got it. I know a
to
lot
be.
about time.
I got it loaded up. I got a Tumblr post. It says Tumblr on it. Oh my gosh. It came from Tumblr. So you've got like the old time cube concept of
Okay.
a rotating sphere. You've got a rotating planet,
Yeah.
and because
Yeah.
of the way it works, because half of the day, half of this planet is at day and half is at night, and a quarter of them are getting up and a quarter of them are going to bed, and
Right.
in one place it's midnight, and on the opposite side it's
Yeah.
noon
Yeah. Yeah. Yeah.
or whatever. It's sort of like there's 4 days going on at once on
Yeah. Yeah.
planet
Okay.
Earth.
Where are you
On
going with
Earth.
this?
Well, it's sort of like that,
Oh.
there's more, because
Ooh.
the Earth doesn't rotate perfectly upon a
Right.
straight little delicate axis. Its
Yeah,
axis
we're tilted now.
rotates around in a number of different ways. The axial tilt um, tips around over the course of like 41,000 years. It goes all the way around. or something. But that's just
Right.
one rotation. Other rotations are caused by other things, and they're not as intense as this 23-degree thing. But there's other things called nutations. Nutations sort of just because the Earth isn't a rigid fantasy math ball, it's a real thing. So when it rotates, it doesn't just perfectly spin, it bounces around on itself a bit. And it reverberates and it pushes itself around. And this is called nutation. And you can see a top do it. After a few seconds, when you drop a top, it'll start spinning around in a circle instead of perfectly upright. And when
Right.
it's doing that circle dance, that's called nutation. And so the Earth does nutation. And one of the nutations it does is called the Chandler wobble. And the Chandler wobble is the amount of space, kind of the amount of absolute space in there where the Earth bounces around itself to rotate. And that's about 30 feet. So
Okay.
the Earth is kind of geomagnetically and polar. If we talk about the pole, bounces around like in a circle, and it also moves in a circle over time. So time being the fourth dimension, fourth dimensionally, Earth is a torus and not a perfect sphere. It's a
Right.
it's a bouncy donut top, is what it is.
Yeah. Okay. Gotcha. Okay, I understand now. I understand the concept and what you're trying to say. I get you. I got you.
So, because it rotates around, because it bounces around in a circle, instead of perfectly beep boop beep boop beep boop, it goes wee wee. This rotation is conserved in time, and this rotation, beyond producing this epicycle, okay, I don't know, I'm getting ahead of my cycle. The time cube has 4 days, but because of the rotation, all these transitions add up. You actually have 5 days in one, not 4. Because there's a whole nother day in the transitions from the quarterly positions of the time cube. So you've got the quarterly positions of the time cube: morning, evening, morning, evening, night. You got the time cube. I'm trying to explain it to Raven when it's on the screen because he can't see the screen.
I understand. I understand what you're saying. I get it. I get it.
So, but really, it's not like a cube. It's like a donut. Well, you've got 5 kinds of days in one donut made of spheres. Now, the smallest number of spheres you can make a real donut out of, I believe, is 5, not 4. And that's why there's 5 days in one donut Earth a day, not 4 in one cube Earth. All right, we can move on now that I've tortured everyone.
It's very interesting. I understand. I see the concept of it. It's part of it. I can believe part of it. It's like a whack job, but it's okay because having an open mind is having an open mind.